Hello everyone, good morning. Welcome to Conf42 Site Reliability Engineering series. My name is Sharath Adupa. I have over 20 years of experience in IT industry. In my career, I worked in financial sector and in health sector. In this session, I want to talk about blockchain technology. Blockchain technology represents a new revolutionary paradigm in digital record keeping, transforming how organizations think about data integrity and security. Welcome to my session. At its core, blockchain functions as a distributed digital ledger that records transactions across a network of computers in a way that makes it extremely difficult to alter or hack existing records. The significance of blockchain in modern data security cannot be overstated. In traditional centralized systems, data vulnerability stems from single points of failures and inherent risks of centralized control. Blockchain technology addresses these challenges by implementing a decentralized approach where data is distributed across multiple nodes. The core value proposition of blockchain includes cryptographic security, immutability, transparency, and smart contracts. Cryptographic security. Blockchain utilizes advanced cryptographic techniques to secure transactions and protect data integrity, making unauthorized accesses virtually impossible. Immutability. Once data is recorded on the blockchain, it becomes impossible to modify without detection, creating an unbroken sequence of verifiable records. Transparency. This technology creates a trustless environment where participants can verify the authenticity of transactions without relying on intermediaries. And smart contracts. The self executing contracts with terms directly written into code automate compliance and reduce the risk of human error in data handling. The foundational architecture of blockchain security leverages distributed ledger technology called DLT to fundamentally transform traditional approaches to data integrity and verification by maintaining synchronized cryptographically secured copies of the entire transaction history across numerous and independent network participants. Blockchain creates an ecosystem where no single entity controls the data. This architectural approach not only eliminates vulnerable single points of failure, but also establishes unprecedented levels of transparency and auditability while maintaining robust security guarantees. Core security features. Immutability. Immutability stands as the cornerstone of blockchain security architecture, ensuring that once data is committed to the ledger, it becomes permanently recorded and resistant to modification. In enterprise grade blockchain implementations, transactions achieve immutable status only after passing through rigorous consensus validation, typically required 6 independent confirmations in Bitcoin derived protocols. Decentralization. Blockchain does not store any of its information in a central location. Instead, the blockchain is copied and spread across a network of computers. Whenever a new block is added to the blockchain, every computer on the network updates its blockchain to reflect the change. By spreading the information across a network rather than storing in one central database, blockchain becomes significantly more difficult to tamper with. Transparency and anonymity. Blockchain strikes a unique balance between transparency and privacy. While all transactions are visible to the participants, personal identities remain hidden through cryptographic addresses. Example, in Bitcoin, users are identified by their wallet addresses, not their real identities, ensuring privacy while maintaining a transparent transaction history. Cryptographic implementation. Blockchain uses cryptography to secure data and verify transactions. The two key cryptographic methods are hashing and digital signatures. Next is security best practices. The comprehensive risk mitigation through scheduled third party audits and formalized incident response frameworks. Industry applications in financial services. Traditional banking transformation. Reduction in settlement times from T plus 3 to near real time execution, with operational costs reduced by 30 to 50%. Cross border payments or foreign exchange rates. Transaction time is reduced from 3 to 5 days to minutes through blockchain networks, improving efficiency and reducing cost. Smart contract automation. KYC or AML compliance processes are automated, reducing verification times from weeks to hours while maintaining comprehensive audit trails, operational efficiency, enhanced data integrity with 99.99% of accuracy in transaction records, and complete elimination of data duplication issues. Now, let's talk about supply chain management applications. Now, the supply chain management applications have end to end visibility, product tracking, time reducer from days to seconds, providing real time supply chain transparency, documentation improvement, documentation errors reduced by up to 95% while cutting administrative costs by 40%. Product provenance, the counterfeit product infiltration reduced by 97% in pharmaceuticals and food safety industries. Recall responses, product recall response times improved from weeks to hours, enhancing consumer safety. Healthcare, healthcare and IoT applications. In healthcare sector, blockchain revolutionizes healthcare by enabling secure, HIPAA compliant sharing of electronic health records. Industry implementations demonstrate 70% reduction in data reconciliation workloads, eliminating redundant processes. 85% improvement in critical data accessibility during patient care. Seamless interoperability between providers with patient records accessible within seconds rather than days. In terms of Internet of Things, IoT of Things, enterprise IoT ecosystems have established a powerful symbiotic relationship with blockchain technology. Advanced implementations reveal 80% reduction in security vulnerabilities compared to traditional centralized systems, 45% enhancement in end to end supply chain visibility and traceability, 60% decrease in unplanned maintenance downtime in smart manufacturing facilities. By integrating blockchain with healthcare and IoT infrastructures, organizations create resilient, transparent systems that not only safeguard sensitive data but also dramatically improve operational efficiency and patient outcomes across both sectors. Implementation benefits. Enterprise blockchain implementations deliver transformative operational efficiencies, reducing dispute resolution timeframes from weeks to mere hours through transparent, cryptographically secure transactional records. This enhanced trust architecture enables organizations to establish new business relationships with unprecedented speed, slashing partner onboarding times by 60% while maintaining rigorous security and compliance standards. Future implications and challenges. Integration challenges. Enterprise systems devote 30 to 40% of project timelines to ensure legacy system compatibility. Regulatory considerations. Organizations allocate 40 to 50% of implementation budget specifically for compliance and regulatory adherence. And scalability solutions. Current blockchain architecture is limited to processing 100 to 300 transactions per second in enterprise environments. Along with this, the organizations implementing blockchain face critical hurdles, particularly talent acquisition, with 75% of enterprises struggling to build teams with blockchain expertise. The financial investment presents a sustainable barrier to adoption, as robust enterprise grade solutions require capital expenditures up to 500,000 to $1 million for comprehensive deployment. The complexity of integrating blockchain with existing business ecosystems results in implementation timelines extending 50 to 60% beyond initial projections, requiring significant organizational commitment. The other blockchain issues are related to governance, interoperability, and technical infrastructure challenges. Let's begin with governance issues. 40% of enterprise blockchain projects face delays due to governance related decision making processes, creating significant implementation hurdles. The governance challenges include complex stakeholder management, unclear decision authority, and evolving governance frameworks. If we talk about interoperability limitations, only 15% of current implementations successfully achieve cross chain functionality, limiting the potential for broader ecosystem integration. These limitations are related to protocol incompatibility, data format inconsistencies, and limited standardization. If we talk about technical infrastructure challenges, organizations report significant concerns regarding transactions finality times, with current implementations averaging 3 to 5 minutes for final settlements. These are These issues are related to network performance issues, security investment requirements, and scalability constraints. The future of enterprise blockchain. Our comprehensive analysis of blockchain's role in contemporary enterprise systems demonstrates its profound capacity to transform data security and integrity paradigms across diverse industries. As this technology matures and adoption accelerates, organizations that strategically integrate blockchain solutions gain significant competitive advantage through enhanced security posture, streamlined operations, and access to novel business models. Forward thinking enterprises that navigate implementation challenges today position themselves at the forefront of the next generation of secure, efficient digital business infrastructure. To conclude, in this session, we talked about the different core value propositions of blockchain technology, the fundamental architecture of blockchain security, core security features, industry applications in different domains like financial services, supply chain management, health sector, and IoT, and statistical representation of benefits of blockchain implementation and the future implications and challenges. I hope you all liked my session. If you have any questions, you can reach out to me at my email address at sharathchandra.adupa@gmail.com. Thank you everyone for listening to me.